The Betelgeuse supernova is one of the most anticipated astronomical phenomena. Betelgeuse is a red supergiant star reaching the end of its lifespan on the well-known shoulder of Orion. Betelgeuse is one of the brightest stars in the night sky, yet it strangely began to dim in late 2019. Because the dimming was so clear, it was possible to detect it with unaided eyes. For several months, the brightness of the star waned, and watchers wondered if Betelgeuse had reached the end of its existence. Though the red giant star's brightness returned to normal after a few months, scientists were startled to uncover the evidence of the great dimming when they concentrated some of the most powerful telescopes on it. As it nears the end of its life, this star is on the brink of exploding. When and why is a supernova likely to occur? And would this be catastrophic for Earth? Let's investigate. Betelgeuse, a magnificent ruby-red dazzling star, is found in the top right shoulder of the winter constellation Orion the Hunter. It is the second brightest star in the constellation after the blue supergiant Rigel, and is also known as Alpha Orionis. Because of its fluctuating nature and unusual name, Betelgeuse is an attractive object for star studies and observations. Even though Rigel, Orion's other great star, is brighter, stars with the designation Alpha are typically the brightest in their constellation. Betelgeuse is Alpha Orionis and one of the most well-known stars due to its name, brightness, size, and reddish colour. Betelgeuse is the seventh brightest star visible from most of North America, Europe, and Canada, and the 10th brightest star in the sky altogether. The Arabic phrase that inspired the name Betelgeuse is commonly translated as the armpit of the giant. Surprisingly, scientists have been unable to determine Betelgeuse's exact distance from Earth. While they estimate it is between 430 and 724 light-years distant, Betelgeuse is the brightest and nearest red supergiant star to Earth. Only 200 red supergiant stars have been detected in our galaxy. Betelgeuse is 16.5 times as big as the Sun, has 126,000 solar luminosities, and can be seen from 548 light-years distant. It has a surface temperature of 3,600 Kelvin, making it cooler than the Sun. Only around 13% of Betelgeuse's radiant energy is visible light. If human eyes could see light at all wavelengths, Betelgeuse would surpass Sirius as the brightest star in our night sky. Betelgeuse has a radius around 764 times that of the Sun. If this star replaced our Sun in the solar system, it would be able to reach beyond the asteroid belt and even Jupiter. This means that the planets Earth, Mars, Mercury, and Venus would be entirely swallowed. Every 10,000 years, Betelgeuse loses around one solar mass as a nebula surrounds the red star due to material being expelled unevenly from the star in all directions. Betelgeuse is surrounded by a cloud of material 250 times larger than this star, and the size of this nebula is likewise considered to be 30 astronomical units, AU, or 30 times the Sun-Earth distance. When a star is born, it is composed of hydrogen, which fuses together in the star's core due to gravity to generate helium in a nuclear explosion. During the fusion process, a lot of heat and light energy is typically released. This energy travels to the star's surface and is released as a photon into space. As the star ages, its primary fuel, hydrogen, runs out, and helium begins to combine with carbon. After the helium is used up, neon will eventually combine with carbon to form iron. When this happens, the fusion of neon with iron absorbs energy rather than releasing it. Because there is nothing to counter the star's extremely strong gravity, when iron starts to fuse, the star collapses in on itself, resulting in a supernova explosion. A supernova, one of nature's most powerful explosions, can produce enough energy to power 10 billion suns. Stars change colour over time, from the youngest, hottest blue forms to the older, cooler red kinds, depending on where they are in their stellar development. Ptolemy, a Greek scholar who lived from 90 to 168 AD, curiously referred to Betelgeuse's colour as ruddiness. However, 3 centuries ago, Chinese astronomers described the star as having a yellow appearance, potentially hinting that Betelgeuse was formerly a yellow supergiant. Despite being just about 10 million years old, bigger stars usually burn up their hydrogen quicker and die out sooner. Betelgeuse is unquestionably reaching the end of its existence. At nearly 5 billion years old, our Sun, on the other hand, is still in its prime. Furthermore, because Betelgeuse is towards the end of its lifespan, a supernova may occur eventually. However, when Betelgeuse's supernova will occur is widely debated. Betelgeuse experiences 2 dimming and brightening cycles, the second of which happens every 5 years and lasts around 100 days. The outer shell of the star is assumed to expand and contract during this cycle, altering the diameter and average temperature of the star with each step of the cycle. Betelgeuse's irregular fading in 2019 and 2020, followed by a temporary return to its typical brilliance, received a lot of attention. Astronomers believe it might imply that the star is likely to die. Betelgeuse has been the subject of extensive research since the 1st century BCE. But why did it wane suddenly and contrary to its typical cycle? Betelgeuse was ejected from its home in the Orion OB1 association, which contains the stars in Orion's belt, and has been travelling across the interstellar medium at a speed of 30 kilometers per second. This racing star generates a bow shock that is more than 4 light-years wide. In astronomy, estimating the distances to red supergiants like Betelgeuse is challenging. For a multitude of reasons, determining Betelgeuse's actual diameter has proven to be difficult. Betelgeuse is a pulsating star, thus its diameter fluctuates over time. Its optical emissions change colours and diminish with distance from the centre owing to limb darkening, so the star has no defined edge. The circumstellar envelope, which is composed of material expelled from the star and emits and absorbs light, makes defining Betelgeuse's photosphere challenging. The apparent size of the star fluctuates depending on the wavelength used, making it difficult to compare observations. Within the electromagnetic spectrum, measurements can be taken at distinct wavelengths, and reported diameters can vary by up to 30 to 35%. Photos acquired by the ground-based Very Large Telescope Interferometer (VLTI) and released by the European Southern Observatory in July 2009 revealed a massive gas plume reaching 30 AU from the star into the surrounding atmosphere. The magnitude of this mass ejection, one of several that occurred in Betelgeuse's atmosphere, corresponded to the distance between the Sun and Neptune. Astronomers have identified at least 6 shells orbiting Betelgeuse. It might be possible to discover the cause of these stellar giants' sad demise if the mystery of mass loss during the last stages of a star's existence could be solved. In addition to the star's diameter, questions have been raised about the complicated dynamics of Betelgeuse's extended atmosphere. Although it is unknown how mass is lost, red supergiants play an important part in the recycling of matter that builds up galaxies. Astronomers may be on the verge of overcoming this dilemma owing to advances in interferometric methods. Astronomers used Hubble and other observatories to reveal that the star rejected a significant portion of its visible surface in 2019 and generated a massive surface mass ejection, SME, which has never been observed previously in the behaviour of a star. Our Sun ejects bits of its thin outer atmosphere, the corona, on a regular basis, a phenomenon known as coronal mass ejection, CME. These events are orders of magnitude weaker than those seen on Betelgeuse. The Betelgeuse surface mass ejection released 400 billion times more mass than a normal coronal mass ejection. This explains why, by February 2020, Betelgeuse had lost around 3 times as much brightness from magnitude 0.5 to magnitude 1.7 after it started to decline dramatically in October 2019. Betelgeuse's brightness had been constant for over 10 days by February 17, 2020, and the star had begun to brighten once more. However, 5 days later, Betelgeuse looked to have stopped dimming altogether, essentially ending the dimming event. Given that there were no notable changes in the infrared on February 24, 2020, the recent visual fading looked to be unconnected to the impending core collapse. Another research that day determined that the star's dimming was most likely caused by large-grain circumstellar dust occluding the star. In the research, which employs measurements at sub-millimeter wavelengths, dust absorption is ruled out as having a substantial influence. The fading, however, looks to be produced by massive star spots. Further examination revealed a significant increase in Betelgeuse's brightness. On August 30th, 2020, researchers discovered a second dust cloud emanating from Betelgeuse, which was connected to a recent significant decrease of the star's brightness. In June of last year, it was proposed that the dust may be caused by a cold spot on its photosphere, and in August, a second independent analysis verified the initial theories. The dust is assumed to have been produced by the gas emitted by the star as it cooled. According to Hubble Space Telescope research conducted in 2022, occluding dust may have been caused by a surface mass ejection. The material was expelled from the surface of this star millions of kilometers distant, where it cooled and compacted, forming the star's fading dust. The photosphere, which was about several times as heavy as our Moon, split apart and flew off into space, obscuring the star from watchers on Earth. Even backyard watchers who saw the star's brightness shift could clearly distinguish the fading, which started in late 2019 and lasted for a few months. Even more amazing, the supergiant's 400-day pulsation rate has stopped. Astronomers have been observing fluctuations in Betelgeuse's surface movements and brightness variations since around 100 years ago to trace this cycle. Its disruption reflects the extent of the blast. The disruption may now be explained by a notion that astronomers have proposed. The star is gradually recovering strength as the photosphere renews as well. The star's natural cycle is being disrupted, and the inside is trembling like a bell that has been smashed. These results give light on how red stars age and lose mass, eventually exploding as supernovae when the fuel runs out in their nuclear fusion furnaces. Their fate is significantly influenced by the degree of mass loss. Betelgeuse's extraordinarily nasty behavior is also not a sign that the star will suddenly become well known. Consequently, a big loss event is not always a precursor of an impending explosion. There is still something going on that we don't fully understand, according to experts, who said that a giant star's surface mass ejection has never been detected before. We may observe this novel phenomenon firsthand and utilize Hubble to distinguish surface characteristics like the real-time observation of star formation. Infrared light from the ejected material is still traveling away from the star, so NASA's Webb Satellite Observatory might be able to see it. Betelgeuse's fading has finally stopped, and it may retake its position as the 10th brightest star in the sky. Betelgeuse is approximately 100,000 times brighter than the Sun, making it one of the brightest stars in the sky despite its distance. Such brilliance comes at a price. In order to keep up with Betelgeuse's vast energy, fuel must be burned swiftly, hastening its demise. The star will ultimately run out of fuel and finally collapse under its own weight before exploding into a brilliant supernova. Then, for a few weeks or months, Betelgeuse will become incredibly brilliant, potentially reaching full moon brightness. Throughout the day, it will become visible. When will it happen? Probably not in our lifetimes, but no one really knows with certainty when it will unfold. It might happen today or in a million years. Will the Betelgeuse supernova wipe out Earth? No. The Betelgeuse explosion will not harm or even partially end life on Earth, since it will occur too far away from the planet. Astronomers think that for a supernova to be deadly to humans, we must be 50 light years away from it, whereas Betelgeuse is over 10 times farther away. Instead, everyone on the planet at the moment will be treated to a stunning view of an extremely brilliant star in the night sky. Let's hear your thoughts in the comments section below.